Okay. Yeah, so I'm recording this again. I'll upload it to YouTube. I might just create like a playlist for the class. This way, it'll just be one link. So after today's class, I'll upload this and I'll take the lecture from the previous lecture and I'll put them in a playlist, and then just share that playlist link. So this way, after class, I'm not sending a new link every single week. Might just make things easier to navigate. So, okay. So we're continuing our talk on going from ER diagrams to relations. So I'll remind you that ER diagrams are a way to draw in figure form certain constraints that you would like to have for a database system. In particular, participation constraints. The participation constraints are, let me scroll down here. I don't like it. Sorry, my screen's a bit frozen here. Participation constraints are the lines that connect entities to relationships. And there's thin lines that mean that the entities are unconstrained in their participation. There's thick lines that say you have to have at least one entity or one member participating within the set of entities. And a thin line with an arrow that says that you have at most one, and thick lines with arrows that say that you have exactly one. So these different combinations, there we go. These different combinations can make different types of relationships between sets. These can be one-to-one relationships, many-to-one relationships, or one-to-one relationships. And if it's a one-to-many relationship, that can go sort of in either direction. So just to give a quick example. Here, if you have some entity that has some primary key, here's another entity with its key, and these are connected by some relationship. This entity, A, is representative of some set of tuples, or you can think of them as rows. And likewise, B, you can also think of like a set of tuples. And you can specify, for example, a one-to-many relationship or a many-to-one relationship. Let me change colors on this, actually. Cool. So a one-to-many relationship would be something like this, where you have one member of this set connecting to many different members of another set. Where many to one is just sort of the converse of that. So here you can have many members of a set that are connected to a single member of another set. There's also a one-to-one mapping, which is where every member must participate. In fact, this wouldn't be possible here because the set sizes are different. But here in red would be an example of a one-to-one relationship. there's also this aspect that isn't captured by these words, one-to-many, many-to-one, one-to-one, which is if you can have members that aren't included at all. So, for example, here in this set A, here's a member of this set that isn't connected to anything in set B. So this may or may not be allowed in an entity relationship diagram. It depends on if you have a thick line or not. So a thick line says that you have at least one connection. So this thick line would disallow this this type of occurrence in set A. Thin lines allow for it. What else? And so this type of thing is not captured. This, having a point here, is not captured with these words. It sort of is captured with this one-to-one, because with a one-to-one relationship, everybody has to be connected to somebody else. So sort of this is implicitly not allowed with a one-to-one relationship. But that aside, let me clean this up a little bit. Whatever, this is fine. For the one-to-many and many-to-one relationship, just using these words, one-to-many or many-to-one, doesn't capture if these types of points are allowed or not. But the entity relationship diagram can capture that by adding a thick line. So that's just a quick review. Now, relations, excuse me, the relational model is very, very close to the way that a SQL system works. So there's a way to take the constraints as depicted in an ER diagram, and then to be able to capture them when you're designing a relation. So that's where we're at. Entities are very easy. They just can be represented as a table with a primary key. Of course, each of these attributes in an ER diagram become columns in the table, and there has to be at least one primary key inside of a relation. If there is no specified primary key like this, if I were to get rid of this, SSN, this would still be okay, but the database management system would then just guarantee that no row in its entirety is duplicated twice. So if you were to try to insert another ABC here, this would not be allowed. So if there's no primary key specified, it's sort of the same as just taking all of these together as being the primary key. Okay. Now, entities are very easy, very straightforward. You just create a table. Things get a little bit more complicated when you are working with how to encode relationships. So in this example, this is with an unconstrained participation. Then the way to capture this is to create a table for the relationship. Here I'm calling it the same thing, works in. And the columns of this table are going to be whatever attributes are connected to this relation, as well as all of the primary keys of the related entities. So in this case, the works in relationship is connected to the employee entity. The employee entity has a primary key SSN, so that would become a column, as well as the DID attribute in the department. Furthermore, for those keys that are coming from entities, then those attributes in the table are foreign keys into their respective relations. Okay, all good so far? Okay. So we left off last time just taking this same scenario where you have two entities connected in this way with a relationship, but just changing one participation constraint. And we had two suggestions, which both work. And I'll go into a little bit more detail later on into some of the benefits of them, but I'll put this aside for now. So this is one way of doing it here, which is you still have the works in table, just as before, except you just change the key. So this arrow, this thin arrow, says means at most one. That is to say that one department has at most one employee. So you can capture this by just making the department, the DID, the key, and not the employee. So here, this department is these two entries here are not allowed together because they have the same department number in this column. So this entry trying to add another employee to this department would be disallowed by the database management system. You would get an error if you tried to add this employee in this way. So this is fine. Not allowed. So this is one method of capturing this. Here I've created this works in table, which is another way to write this works in table using more SQL-like language. And another small thing here in the works in table, just because I renamed this key or this this column to be named employee, not SSN. So the way that you would capture this in SQL is to take the foreign key and reference the particular column that you want it to point to within the employee table. Here, just to contrast, if I named this DID, I'm going to make that a key, then this would be now called DID, and it's a foreign key that references the department DID. In this case, this is sort of redundant, so you could write it like this if you just feel like being explicit. Otherwise, you could write it this way, and by default, it will just assume that the foreign key here, DID, has the same name as the primary key that it's pointing to. Okay, so this is, I'll call it method 1. Let me try to do this, trying to come up with an efficient way. Okay, method 2. A second way you can capture this is to not create another works in table, but to instead extend the department table. It's closer. So here, the social security number is a foreign key into the employee table. The department table already has as its primary key the DID, and so this is another option. This still captures this constraint up here. One employee can work in many different departments, but one department can only have one employee. And that this is implicitly capturing it because here, this primary key, DID, is already acting as the filter to make sure that a department doesn't show up more than once. So here, this is not allowed. For the same reason as this example where we had a separate table. Is it possible to make the department a unique key and since plus employee a composite primary key? Are you talking about in method 1 or method 2, Toyin? Method 2. So if let's see. So first of all, is it possible to make the department a unique key? Here, maybe not, because a unique key allows for null values. And so if I were to make DID a unique key and SSN and since a composite key, then you might be able to have a null value here. But then SSN, I don't know, 3, 3, 3, 3, and since, I don't know, 5, 7, 18, who cares? This would be allowed because this just is a unique key. But that is sort of a strange thing to have in a department table. I mean, a department with a null value. So it would be better to make the DID the primary key because primary keys do not allow for null values. Allowed if unique key. Not allowed if primary key. Yeah. So, and having a SSIN and since as composite keys, this would just allow for having or rather prohibiting an employee to work in two different departments at the same time, which I guess it depends. I mean, that constraint isn't captured in this relationship. Okay, so okay, this one. Well, I don't really want to say that things are easy per se, but I'll move on to another example. If you have same colors. Here I'll just write something simpler, A, and this has some primary key A, and through some relationship R with another entity B with primary key B. Okay, is there anybody who can sort of just say in words what this entity relationship diagram is saying about the relationship between A and B? It's a one-to-one relationship. Yeah, sure. So it's a one-to-one relationship. This is saying that members of A are connected to exactly one member of B, and also that one member of B is connected to exactly one member of A. So, for example, this. Right. And this implicitly says that the size of A is equal to the size of B. So this arrow means implies. That means it's an implicit constraint. It's not. I'm not codifying this anywhere, saying that it has to be this way. This is a consequence of having this type of one-to-one relationship. Okay. So how could we capture this as a relation or in the relational model? If you think you might have an answer, you can unmute your mic. Or otherwise, you can also type, I don't know. Can I? Yeah. So this is now talking about this ER diagram. How do I turn this into the relational model? So using tables like these in green. can you just make, I guess that's them, have the same primary key? Brian, do you have a mic?
Can you hear me?
Yes.
I don't know if this is right, but can you just make like them have the same exact primary key so that um like if you have an employee table and then you have your department table.
I'll just use
mm,
tables A and tables B.
Okay.
Okay.
So I feel like if you were to make A have a primary key and
Okay.
then B have a column where the primary key is the foreign key to A's primary key. I don't know if that makes sense.
Like this.
Yeah, kind of.
Okay. And how about B here?
So B's primary key would be the foreign key to A's primary key. I don't know if that makes sense. Like,
Okay. So B would have two columns, one B and one A.
or it could just have A, and
Okay.
then that way.
But there's this B here that needs to be somewhere.
Oh, I see. Um, so can you put B in there but make A the primary key alone?
Put B in there. In
Put
where?
B in the B table, but
Okay.
not make it part of the primary key, and just make A the primary key and make it foreign to the primary key of the A table.
Okay. So let's see. If this is a primary key, I can't have more than one here. Uh, so uh, would this be allowed in this model?
So
And I guess here you'd have 1 and 2.
I'm not sure.
Okay. Yeah. So this wouldn't violate anything. Thank you, Brian. Yeah, thank you. So this would be allowed in this model because nothing is violated. Here, A is a primary key. There's no repeats, so fine. Same thing here. A is a primary key here, as well as being a foreign key into A. Um, the primary key constraints are satisfied because there's no repeats in this column. And the foreign key is satisfied because any key that appears here also appears in A, or in table A. But here you have a member of B connecting to two different elements. So this is a problem. Yes. So a single table. All right. So we'll call this table AB, whatever. Uh, can everything just go into one table since each row in A will match one row of B? Yeah, I'm thinking only one table is needed as well. Okay, great. So we have one table. Let me erase this. This is looking better. Okay, how about the keys? One key, two keys, composite key. I guess that's about all the different choices you have. Two keys. Yes, exactly. So here you would have two keys, no member here. So for example, we'll see what we want. here. I'll use even and odd numbers, I guess. 2, 4. So this should not be allowed because now a member of A is connected to more than one member of B. And indeed, this is not allowed by these constraints because that would violate this key constraint. Similarly, for B, if we had this would not be allowed because it violates this B constraint. And yeah, no nulls allowed. So that is to say, if you were to have a member here, like an A, where maybe this is a null value, and sorry, whatever, this is null and connected to nothing, 2. This is also not allowed because primary keys don't have null values, and great. So that's good. Right. So when you, if you were to actually write this table, in fact, let me just do it. Keep the same font here. So I'm calling this table AB, and it has A, has a B. I'm sure they can be characters. Right. Now, you can only have one primary key, so we'll make that A. And here, you would have unique B. Now, by default, this would allow B to have nulls because B is just unique here. So you can avoid that by adding a not null constraint here. And that's it. Okay, I will go on to the next example, unless people have questions. No. For a unique key, can you have multiple null values? Yes, you can. Right, yeah, that's a good question. Because a null might be repeated, and if it's unique, how can you have things that repeat? It's allowed just for null, but no other value. Good question. Okay, let's get more room here. Okay. How about here we're going to say employees, they have social security numbers that are unique. They have names that might not be unique, and they have a parking lot, same as before. Except now, the relationship is going to be with itself. So what we want here is that employees are going to have supervisors. And if you're being supervised by somebody, then you are a subordinate. So subordinates report to their supervisors. Oh, what would be an example where you would use a unique key? I think we had an example up here, did we not? Let's go to the relation here. Okay. Yeah, you're saying, so what would be an example where you would have a unique key where the value can be null, and that's not a problem. Is that right? Karina? Yes. Um, let me think. So it could be, for example, students that have a parking space, for example. So only one person per class. Yeah. So with a lot, like if you're assigned instead of a lot, you're inside a parking space. Well, employees shouldn't be assigned to the same parking space. So they should be unique. But that being said, maybe some people bike to work, and so they don't have to have a parking space. Um, if you have one assigned to you, for sure, there's not going to be any collisions with two people with cars being assigned the same space. But not everybody needs to have a space. But technically, you could use the parking spaces as a unique identifier for employees. The class is in there. Okay. Great. Okay. So, any ideas for this? How do we make this into a relation? No, that is not. If that were the case, then these participation constraints might be different. But as they are now, they are just unconstrained. If you have an idea, you can unmute yourself. It's also helpful if you don't have an idea, you can just say don't know or not sure.
Hi, can you hear me?
Yes.
Okay. So I was thinking that maybe we could make another table and then you would just have a combination of a supervisor with subordinate. Like those would be the columns, I guess.
Supervisor and subordinate, okay. And I'll call this the reports to table. Okay.
And then I guess the supervisor would be the primary key and it would also be the foreign key back to employees.
Okay, yeah, so let me put an employee table here. So this is a primary key with your SSN name lot. Okay. And that's it?
That's all I got. I don't know if there's more.
Okay. Let's see. This is close, but not quite there, because this would only allow one supervisor. right? So if I had a supervisor, one person supervising 2 people, then this, because supervisor is a primary key, this would not be allowed, right?
Oh wait, can we make it a composite key then?
Yes. So again, I'll capture the composite key by kind of connecting them here. Okay? And yeah, that's it. Oh, not quite, sorry. The subordinate also needs to be a foreign key. Okay, thank you very much. Yeah, so that's it. So there's one composite key in the reports to table, each of which are a foreign key to the employee table. And this is, well, there's not much more to say unless there's questions about it. Okay, I prefer if you can actually type yes, no, this kind of thing instead of just silence. Okay, thank you. Then here we'll draw something that looks a little bit more substantial. So we're going to have our employees with a social security number, name, parking lot, and a department with a unique department ID, name, and budget. There's going to be a relationship manages since some time. And there's also going to be another relationship called works in. All right, since some time. And here, we're going to say that an employee must work in a department, and a department must have an employee. An employee might not have a manager, but departments are going to have exactly one employee. So, just to get started, we're going to have an employee table with SSN, name, and lot. A department table with DID, name, and budget. Okay, and let's start off with this relationship. This, well, don't need to do the whole thing. This one. So just to sort of emphasize this point, you might have many employees. Here you have some departments. This is saying that everybody in the department participates just one time. for example. But employees don't necessarily have to participate. So, any ideas for this manages relationship? Manages table. Okay, let's try it.
Nope.
Yes, I can.
So, in this manages table,
Yep.
process key of the department ID have an attribute.
Sorry, say that again.
In the manages table, I think you do a composite key of the social security number in the department and the attribute of
Since with this as a composite key, like this. So let's see. Trying to come up with some examples. Oh. So here's an employee 111, 2. Oh, and I'm assuming that these are foreign keys. Okay, so a composite key, for example, would this be okay? Does this violate anything in this table?
I think so.
I'm sorry, you don't think so? Yes, so this is okay for a composite key, but this violates this constraint in the ER diagram. It needs to have exactly one.
Oh, okay.
Yeah.
So make it a 2 keys.
2 keys.
Primary and the department is unique.
Okay, let's see. So if it's 2 keys, then that wouldn't be allowed. Let's see. Okay, so how about, let's see. Is this violated? Does this, so this, here, there's a violation because of this SSN key, right? But this should be okay because there's no constraints on the employees. You could have an employee in more than one department. For example, maybe this is okay. I mean, a department still has exactly one employee, no constraints on the employee. You could have an employee be a member of 2 different departments, but in this table, there's a violation here. So that's a problem.
Primary and
Sorry, what's the, yeah, make the department the primary key. Right, so now this would be okay. Yes, this works. Yeah. So this works as this is okay. The one thing to keep in mind, let me copy this. We're going to have a table manages with SSN, DID, and an int, primary key DID, and we would have foreign key SSN references employees and foreign key PID references department. And since. Great. The thing to recognize here is this, the not null. Oh, I'm sorry, that's in the wrong place. Here, this would go in the SSN. So the primary key is the department, and this enforces the arrow part here, that you have at most one. But for this thick line part, see if I can. So this addresses the thick line, and this addresses the arrow part of the relationship. Can't two tables not have the same primary key? I don't think that there's an issue with this. No. Does it matter which direction the arrowhead follows in terms of DID manages table, DID department table, or other direction? You mean here, if I draw the arrowhead here, or if I draw the arrowhead here? I mean, I don't think it's a big deal. It's not the type of thing that I would take points off on or anything, but the convention is to have DID as a foreign key that points to a key in this way. So yeah, this is the convention. But that being said, if you draw it the other way, it's such a trivial thing, I don't care. Okay. Okay. Another solution to this could be to extend this table with a social security number and since, sorry, that is not a key, where the SSN is a foreign key. So in green here on the bottom, this manages table is sort of the first method. Here, this blue table is sort of using the second method. And you're able to do this because of the arrow. You have a primary key where you only want this to appear at most once. And so this department table having a primary key DID is sort of pulling double duty, making sure that it's a primary key for the department entity, but this can also enforce the arrowhead part of the constraint that no department is going to have two managers. Yeah. And I just want to emphasize again to Matthew's question, it's fine for two different tables to have the same named entity as a primary key. There's no problem with that. So here, manages this table has a primary key DID that is also a foreign key. It's both a primary key and a foreign key. And this department table has also a department ID primary key. No problem with this. Okay. Let me try to make some room here. Okay. All right. Now let's focus on this part. How would we capture this works in relationship? So this is just a thick line, no arrow. This means that there is at least one. There is at least one employee that works in some department, and each department has at least one employee working inside of it. I'll give you a minute to think about it. Create a works in table, okay? Do that here. Myself some more room. Employees department since. Sorry, Jamie. Jamie, can you unmute your mic? Or do you have a mic?
Yes.
Okay. So an employee department since, and make this a composite key. Is that right?
Yeah, someone else said that, but I agree with that.
Oh, okay.
I'm just not sure if that captures the at least one part of it. Like I'm not sure if that captures the requirement that we need at least one employee in a department and each employee needs a department.
Right. Yeah. Yeah, this doesn't capture that. So there's a problem with this. This is an NDID. Oh, yeah, I mean, whatever. Like, you can name things like this if you want. You can name these columns sort of whatever you like, because you can always, like here, I named this this column employee, but I can just have it reference. I can be explicit which column it's referencing. Sort of a preference thing. I mean, I guess some people might think it's cleaner to have the same names everywhere, but sometimes it might be, I don't know, easier to think about in different relations, something if you call it a different name. Yeah. So this you cannot do. Yeah, it's a little bit of a, well, I guess it is a trick question. This is, you cannot capture this in a relational model. So there do exist things, like explicitly this, in ER diagrams, constraints that are valid in an ER diagram that just can't be captured in a relational model. So, yeah, it's just something that, can you say, cannot be null? Somewhere in the code. Yeah, you could say it can't be null, but let me try to think if I can come up with a more explicit way of trying to explain this. Let's say here we have a table T1, and we have another table T2. So this would be like the employees relation here, and maybe there's 6 employees. 6 employees. And there's 4 departments. And now you're trying to create another table, works in. And I'll also just reiterate here, this sort of method 1, method 2, it should always be the case that you could create another table like this. There's reasons why you might prefer method 2, but you're never forced to only extend an existing table. You can always create another table and achieve the same result. I'll get to in a minute why you might prefer one over the other, but each are very valid ways of doing this. So, what this is saying, this line, wait, where's my drawing thing? This thick line here is saying that each employee must work in some department. So each entry here must appear somewhere in this table. At the same time, this thick line, oh, well, no. I don't think you need that. So let me draw it this way. What I mean by this blue arrow is that what appears in T1 must appear in T2, or in T. And this arrow is saying what appears in T must appear in T1. there's no way to encode this. Like, this is, I don't know, you can sort of sit down and try to work through it, but there's any solution that you try to offer, there will be some counter example where you're not capturing something. So let's see. Oh, an equal number of entries. Right. Yes. So that's, yes, that's for this table T and T1. T2 might have a different set. I mean, you could have you could have fewer departments than you do an employee. Departments have at least one employee. Employees work in at least one department. But yes, that would be also implicitly captured by this, by these here, that they would have equal size. And you can say in this table here, for example, there's this not null value that exists, but this doesn't capture the fact that what appears in one table must appear inside of another table. You can say that if a value exists here, so for example, if this is a foreign key, I don't know, this has a foreign key into this table, you can say that if this appears here, A, then A must also appear here. But you can't say that A must be used in this table. This direction is okay. This direction is not okay. There's just no way in the relational model to say that everything in this table has to appear in this table. There's just no way to capture it. The foreign key says if something appears in this table, then it must appear. If something appears in table T, then it must appear in T1. But you cannot say for each entry in T1, it must exist in table T. So that is just a limitation of the relational model. How can I emphasize this? I want to use different colors, but I also don't want it to make it look like I'm vomiting a rainbow. But this would be a good exam question. What's something you can do in ER you cannot? It's 2 words. Do in relational model. Okay. Sorry about all the colors. I don't know if it's helpful or if it's distracting. In any case, are there any questions about this? No. Okay. Then I just have one last example, and then we'll be finished with this. Okay. We have the same. Employees, social security number, lot, and name. We have a policy and dependents. And making this thick. Oh, dependents have a name and an age. So this is an example of a weak entity. I'll remind you, so a weak entity is captured by a thick box and a thick arrow. That is a weak entity. And a weak entity also has a key that is a dotted underline. So that is to say that it's not unique in the case of a weak entity. A weak entity is supposed to capture when the only reason why something would exist in this entity is because it's attached to some other member of another entity. In this case, the P name is connected to the employee. So in this example, there might be an insurance policy. You have two employees, each which have a daughter, Sarah, and this is fine because even though both of their names are Sarah, the social security numbers of their parents will be different, and so it will be this combination of that uniquely defines a dependent. So this defines a dependent. That is, the combination defines a dependent, not just the P name. So that is okay. Good to know. Thank you, Francesco. Right. So that's just a quick refresher on a weak entity, and just because there's not much time, I'll just go ahead and show what this would look like. Now let's call it policy. So there's going to be a P name. Oh, sorry, I forgot one thing here. Policies cost money, unfortunately. Age is going to be an integer. And in addition, this has a social security number. And the primary key, again, is the combination of P name and social security number. So although this P name by itself is not a unique identifier to a weak for the weak entity. All entities have some primary key that uniquely defines it. Weak entities don't. Weak entities instead sort of inherit that from another entity. So this is where that inheritance is happening. Members of in this policy get their uniqueness from the social security number from the employee's entry. And the social security number is going to be coming from employees. And in addition, this is the sort of important part. Why is that going small? Let me make this look a little better. Okay. So, in addition, for weak entities, the only reason for their existence is because of some other entity. That is to say that if an employee has a child that's covered by their insurance, then if that employee leaves the company, that dependent also loses their insurance. So that's what this on-delete cascade is. This is a foreign key. This SSN here is a foreign key that points to this employee key. But if that employee gets deleted, then anything that's pointing to it, namely this entry, pname, all of this, also gets deleted. So that's what this means. Yes, pname SSN defines a dependent. Here. That's the key. Yes, this dotted line means that this is not unique. The pname is not unique by itself, but the combination here is. Pname and SSN is a composite. Correct. Yes, because an employee might have many children. So if somebody has 2 kids, you want both of them covered. So the social security number would appear 2 times, but the combination of that social security number and the name of the child is unique. Unless somebody names both of their kids the same name, this isn't a problem. And that is it. So I'll hang around if you guys have extra questions, but you don't have to. I will put this recording online, and this covers everything that I have to say about converting ER diagrams to the relational model. Okay.